Welcome to today's webinar, Highly Available SQL Server on AWS. Our presenter is Matt Tavis, Principal Solutions Architect with Amazon Web Services. As a Principal Solutions Architect, Matt Tavis works on the AWS partner team with enterprise customers and partners to provide architectural guidance and to help AWS customers understand how to best utilize AWS. Matt has been with Amazon since 2005 and has been working with Amazon's web services offerings throughout that entire period. Prior to joining AWS, Matt worked at Microsoft designing web services APIs and spent many years working in IT consulting for Sapient Corporation. Thank you for joining us today, Matt.
Thanks, Colin. I appreciate the intro. It's so every time somebody mentions the tenure I've spent with Amazon, it's always a great reminder of the great things I've been able to see and the great opportunities I've had to present and talk about the fantastic technology we've been able to build. And today I'm excited to talk about some of the more new stuff that we're providing, not just about how the platform works, but even giving people reference implementations and guides to help them through implementing and building these solutions that are common for our enterprise customers. As you mentioned, we're going to talk about highly available SQL Server on AWS, and we'll focus on some of the steps to that. And a big piece of that will also be even a CloudFormation template that can automate that whole infrastructure and allow you to create your own in a quick fashion. So what we'll cover today is an overview of this HA solution using obviously Windows Server, SQL Server, all running on top of EC2. It goes into using Enterprise Edition of SQL Server 2012 or 2014. As well as always-on availability groups and Windows Server failover clustering. Those are all parts of this entire solution. So this is how these core Microsoft technologies run on top of the AWS platform. Now it's important to note, I think up front, that this is not going to talk about the RDS HA SQL Server solution that we recently announced. So this is focused on implementing and running SQL Server on top of Amazon EC2 instances, as opposed to using the relational database service, which we also provide that also runs SQL Server in an HA mode. There's links here on the page as well that you can look at and go follow on how the RDS solution works. There are some differences between them, but this will be much more of a focus of how to sort of do it yourself using core AWS EC2 resources as opposed to using the relational database service. There are scenarios for both. And obviously, they're both worth looking at if you need an HA solution on top of AWS. But this one will focus specifically on the Microsoft technology side of things and how it sits on top of the AWS platform using core infrastructure resources such as Amazon EC2. Before we get started, I think it's important to note that this is a fairly advanced topic. If you're not familiar with AWS at all, there's obviously a lot of kind of groundwork that you'd need to lay to really understand some of the components of what we're talking about here. We will dive in pretty deep and pretty quickly into some of the lower layers and automation capabilities of the platform. So if you're not familiar with, say, EC2 or VPC, or even the Microsoft technologies such as Windows Server Active Directory, DNS, failover clustering, or always-on groups, then these are things you're going to want to go do some research on. Obviously, the Getting Started sections of AWS will cover a lot of the AWS technologies, such as EC2 and VPC. Obviously, the Microsoft Windows Server technologies will be covered on Microsoft's websites to describe those components in more detail. So if that is something you're less familiar with, then feel free to open another window and follow along, or obviously this will be recorded and you can do some research on those and watch this again and see how once you have a greater foundation in those, how those technologies are being leveraged in this particular solution. But with that being said, I'll dive right in, assuming we're all familiar with the items listed on the page, and we'll go on to the next section. So the real goal here, I won't read this whole slide, I'll leave that to you. The real goal here is to show specifically how you can automate and set up a highly available configuration, to avoid single instance failures for a SQL Server, a clustering model. So Windows Server failover clustering is leveraged for that. We'll show how to set that up. We'll talk about Active Directory, which is a core foundation for that as well. And then we'll also go into always-on availability groups, a Windows Server function that allows for automated some form of automated failover and fail back. and then we'll talk about CloudFormation. So the goal here for you is to show you kind of the components and the steps of how you might do this yourself. What are the key things to consider as part of that architecture? And then provide you with links and information about how you could do this on your own. And using, we provide behind this presentation is a white paper by Mike Pfeiffer. Latest version just was recently released. And so that's covers the details behind this, as well as CloudFormation templates that show how to build that platform. What's important, there's some core things that are important in terms of requirements that need to be met for this kind of a solution. And obviously, one of the key steps is we assume and we put all this inside of a virtual private cloud, or VPC, as we term it, which allows you to deploy the cluster nodes inside that using multiple availability zones, using subnets across those availability zones. That's one of the core bases, and we'll see that in the architecture diagram. And the other component is that the Windows Server failover cluster nodes need to be in separate subnets. And in fact, our recommendation is separate availability zones. So you have zone level and availability zone level isolation for failover scenarios. So those are some of the core foundation components. And we'll cover more detail on the steps to go through to create this whole thing. Before we dive in too much, though, a common question that is asked is what is the support from a licensing perspective using the Microsoft platform on top of AWS? And there's really several layers to that. I'll talk generally here about what those layers are, but then I'll talk specifically about the scenario being used in this example. There's two major licensing models for Microsoft products. For Windows Server or SQL Server Standard, or Express or Web Editions, we actually provide pay-as-you-go AMI models where you can pay by the hour for SQL Server Standard or Windows Server, and those can be included in your hourly costs as you run EC2 instances. And there's also another layer, which is what we call BYOL, or bring your own license, which is how you can leverage existing licenses that you might have in the enterprise and move those over. And this is actually part of Microsoft Software Assurance capability and license mobility. And once you have software assurance with Microsoft, there's a wide array of server licenses that can be moved and run on top of AWS. Things like SharePoint, SQL Server, Link. Many of those products can be run on top of AWS as part of software assurance. This particular scenario is going to be using SQL Server Enterprise Edition, so not the Standard Edition. So in that mode, it is a bring your own license model. So you would acquire licenses for SQL Server Enterprise Edition, use the software assurance components of that licensing, and leverage those to bring those licenses into the AWS platform. So that's a key component to note about this particular approach. And so that's something to know on that model. Now, this scenario and the CloudFormation templates do install the trial products by default. So you can actually set this up, spin it up, and try it without actually any license mobility needs. But for a production workload, or even for a staging and dev environment that's going to be standing for a long time, you would want to move over those production licenses to the AWS platform. So now we can dive into what we're going to learn here. So there's three real big parts to this. The first part is to implement Active Directory domain services. This is a core foundation for many Microsoft server technologies. If you're familiar with Microsoft, server platform, Active Directory is nothing new to you. That's really something you have to build and create. And that part one also includes building a virtual private cloud to host those nodes in. So that'll be this first step, is laying that, if you will, domain infrastructure foundation. The next step is really to launch and configure the server infrastructure. So this is launching EC2 instances, installing SQL Server Enterprise Edition, configuring it. And then the third is configuring a SQL Server 2012 or 2014 always on availability group. So those are the big three steps that are really part of this CloudFormation template and white paper. And so those are the things we're going to dive into today. So what you're going to build, or what this will build if you follow these steps and use this CloudFormation template, is several high-level components, and then per availability zone components for each availability zone in the platform. In the region, I should say. One Amazon VPC, so a virtual private cloud, which defines a large VLAN or network infrastructure within which you're going to place resources. a public route for routing into that VPC, an internet gateway for routing out for the public internet, public subnet nodes. Obviously, security groups, that's again another thing that we're assuming people are familiar with. The security groups control the flow of information between nodes inside the infrastructure and make sure certain ports and protocols are open. Obviously, in something like SQL Server, there's lots of individual ports that need to be open, such as 1433 for accessing the database. That's part of this setup and configuration. It's part of the templates as well, but those need to be created for being leveraged inside the subnets and the instances. And then in each availability zone, we create by default 8 private subnets and 2 public subnets. The public subnets are for NAT instances and remote desktop gateway nodes, or you might put elastic load balancers in there. And then private routes for routing between the various subnets. Windows Server 2012 remote desktop gateway instances, and this is part of the Active Directory infrastructure we'll talk briefly about. NAT instances for routing out from the private subnets to the public internet without exposing and providing public IPs back into that infrastructure. Elastic IPs associated with those instances, and then 2 Active Directory nodes and 2 Windows Server failover clustering nodes of 2012 or 2014. So that's really what's part of this whole infrastructure and part of this guide that we're talking through. What it looks like is somewhat like this. There's a couple of extra boxes in here that I'll explain away in a moment, but those are things to sort of show you more of a broad, complete architecture of what you might ultimately implement using something like this. But in your first line going sort of left to right, you see obviously the external users and remote management tools coming in through internet gateways to connect into the environment, and they connect into that remote desktop gateway. This is part of our Active Directory layer and part of our kind of, if you will, jump host or bastion host layer. This is how you would connect into this infrastructure to manage individual servers. You don't want to give every server in your environment a public IP, so you could use a remote desktop gateway node for hopping into the infrastructure and jumping box to box. Behind that, you see private subnets for web tier, app tier, database tier, and Active Directory tier. Those don't have to be entirely broken into individual subnets. Those could be grouped together as appropriate, depending on what you think makes the most sense for your network isolation or traffic isolation models. We've done it in this case just to show the ability to create subnets for various components or layers of the application, but that's not a required design element. It could be compressed if you so choose. The web and app tier boxes that you see in there, the web front end server and the application server, it says SharePoint 2013 below it. Those are examples of applications that might sit in front of a SQL Server. Those are not part of this template. They're not created by this CloudFormation template that we're talking about today, but that would be where you would place those components given this architectural model. So those are just sort of identifiers of things that could exist, as well as that load balancer to route traffic in there, not created but could exist as part of this model. The key thing what's getting created as part of this is really the primary replica, the secondary replica in the SQL Server instances, as well as the layer behind the domain controllers, which also provide DNS as well as shared storage for the witness model for SQL Server failover and replication. So you'll see there's a primary replica and a secondary replica, and there's a gray box surrounding those two, and that's where the always-on SQL Server always-on availability group is defined, as well as the Windows Server failover clustering nodes are defined and created together. So that's really, if you will, a grouping of servers under the Windows model that shows these machines work together. And you can see they're in different subnets across availability zones, which gives you greater spread of infrastructure and greater isolation for fault tolerance. Should networking events occur in a single AZ, the other AZ would be unaffected. So that is the general model of what's going behind this. So let's start with the implementing Active Directory domain services. This is, I'm not going to spend a lot of time on this section, specifically because we actually did a whole nother webinar on this about implementing Active Directory domain services in AWS, which is online, available, and recorded. It goes into, that particular webinar goes into a little bit more detail about the configuration and setup. But there's some key things to be reminded of in that particular model. Domain controllers obviously are key components, core infrastructure for Windows-based applications and infrastructure, and therefore should be placed in a minimum of 2 AZs spread for high availability. They should be often in individual server tiers for network isolation and flow, so they're not necessarily combined as lots of different roles, but rather the domain controller and exposed appropriately. They should be in private subnets. And of course, they do require those for bootstrapping processes and for reaching back into various locations for automating various bits of the infrastructure. They will require access to the internet to reach back into AWS services such as S3. So that they do have to sit behind a NAT layer, and that's why that NAT instance set or network address translation instance set is provided as part of the buildup, so that those domain controllers can reach back and bootstrap and automate creating themselves. Remote desktop gateways are kind of part of this layer as well, thrown in as a jump host or a bastion host to connect into the infrastructure, and then to further administer the internal private subnet instances. So those are some of the key pieces. There's definitely some discussion of DNS and DHCP. A lot of that's covered in detail as part of the Implementing Active Directory Domain Services on the AWS Cloud webinar and presentation. So I definitely recommend, if that's something you want to know more about, I definitely recommend going back to that webinar and watching that. It will give you a little bit more depth about that particular layer, and I'll show you kind of how those are leveraged in the CloudFormation side of things, and a little bit further in this particular presentation. So that's that step one. Step two is really to launch and configure the infrastructure, and that is broken down into really 4 major components. The first is, setting up SQL Server Enterprise Edition. Let's talk about how that works. Creating and configuring the security groups to allow access between the various layers, so that machines in the app server security group or machines in the SQL Server security group could talk to each other, so ports are open. Creating the Windows Server failover clustering cluster. So that's a step that needs to be created, so it can identify the nodes that are in that cluster. This particular model obviously uses 2, and we'll show how that's done in the template. And then enabling always-on high availability, and that component we'll talk about as the 4th step, if you will, under part 2. So high availability and disaster recovery in the AWS cloud. I think the first step is to think about how do you apply that and create it. And this is nothing unique specifically to SQL Server or any specific application. Really, one of the key goals of how we build out our regions and our infrastructure is to provide you with a region that spreads multiple availability zones. So that means you have the ability to place infrastructure in multiple availability zones, which are somewhat isolated, so that allows you to be more fault tolerant. Should a node fail in a single location, you can fail over to the other availability zones. That's really a core tenet of our high availability design as part of the AWS region design. So our best practices here show you using that. That's obviously very important. And then on top of that, the WSFC provides features that complement that by allowing you to identify the nodes that are in each AZ that are part of this HADR scenario for the Windows Server failover clustering component. So they really work quite well together. We give you the multiple AZs for spread of infrastructure for fault isolation and fault tolerance, and then Windows Server failover clustering adds the software awareness up top that actually talks between the nodes to make sure they're aware of who's up and down. And that's a big piece of this. And so we'll show, and that was in the diagram as well. The next step is to really set up the SQL Server Enterprise Edition. As I mentioned before, the Amazon Machine Images, or AMIs, that are provided are really only for SQL Server Express and SQL Server Web Edition. We do have an RDS SQL Server Standard Edition where licenses are included, but this is the Enterprise Edition, where it is you need to install it yourself on EC2, and you need to bring your own license. So this template actually will install 2012 or 2014 Enterprise Edition, and you have a choice in the parameters of the template. We use the trial software. Obviously, we can't assume your license, and we can't inject one. So that would be something you could then upgrade over time, or you could choose to install from a different location in the template. But we use the trial in this particular example. It's actually actually fully scripted as part of the deployment. So in the CloudFormation template, and we'll go into that a little bit further down, is really the download information for downloading and installing SQL Server Enterprise for both 2012 or 2014. And of course, should you choose to put this into a production mode, you would then install your own licenses using the software assurance model to mobilize licenses into the AWS platform. The next step as part of this is really to create and configure those security groups. Every EC2 instance actually must be associated with one or more security groups. That controls inbound or ingress traffic, egress or outbound traffic, and has granular rules that are scoped to protocol, as in TCP versus UDP, port, port 80, port 443, port 1433, source or destination, which could be an IP address or a subnet. So it could be 10.1.2.0/24, or it could even be the reference to another security group. So it's a very layered dynamic model that you can apply. Obviously, this is an important core concept for network control and flow control inside the environment to protect what ports and protocols are available. These lie completely underneath the operating system in the AWS hypervisor layer. So therefore, your instance will never see traffic that does not pass these security group rules bubbled up to it. Obviously, there's a lot of guidance on securing the Microsoft platform in AWS. We have a white paper around that in our security space. And security group as a general concept, if you want to know more, you should really go to the security portal or security pages where there's a lot of information about how those work. You need to actually set them up though. So this is a core component, is to make sure the SQL nodes have the right ports open to each other to communicate. The CloudFormation templates embed that automatically, and we have a whole bunch of rules created in there automatically to get you going. But that's definitely something that you'll want to familiarize yourself with as well and look at how the template sets that up. And then the third step is really to create the Windows Server failover cluster. There's several parts to this. The first is to establish a storage model. So in this particular template, the default is to use the R3 double extra large or 2XL instance types by default, although that's controllable. In fact, I believe all the instance types in the template are specifiable. You can choose the size of those, so you can change that around. Those nodes those are SSD-based nodes, and they come with some ephemeral storage, but ultimately for a persistent storage model like a database, you would want to run on elastic block stores behind those instances. And in fact, in this case, because performance is often a key factor or consideration with a database, you want to be using provisioned IOPS volumes, which allow you to provision and allocate a certain amount of I/O per second for your individual drives. In order to drive up and actually even parallelize that I/O, we also will create RAID sets. So we'll take, if you look there, you see each WSC node deploys 8 EBS volumes to create three stripe set RAID arrays, RAID 0. So we actually will use RAID 0 as part of this buildup to then say take 2 drives and stripe across them. So you can parallelize the I/O to those drives, which then allows you to increase the potential I/O you can drive through them. So, and then obviously the disk layout for logs and location will be used as identified here in the slide. So we'll have a log volume, we'll have a temporary storage volume, the data volume, and the tempdb volume. And each of those is an individual set, in some cases RAID arrays, in some cases could be individual disks. So you can really control a lot of that. The template creates that for you. And the default in the template is to use multiple provisioned IOPS volumes set for 500 IOPS per volume, but that's a number that you can control as part of the automation. The other piece is to set up the IP addressing for the Windows Server failover clustering. There's multiple IP addresses that you want to assign. They need to be distinct and are created distinct in this model for various roles. So the IP address for the primary IP address for the instance is one IP. The second IP acts as the Windows Server failover clustering IP for the resource. And then the third is as part of the always on availability group listener model. Under the covers, these are actually elastic network interfaces, or ENIs as we call them, which are multiple IPs associated with a single EC2 instance. And you can control those and create those, and those are created as part of the template. And then each one is used distinctly for the configuration of, primary access or WSFC configuration or the always on availability group listener model. So those are created as part of the template as well. And then, of course, the third step is third part of this is really to create the server for clustering model. You can see actually we embed this in the template, but there's some very simple PowerShell commands to create that cluster. You can create the failover clustering nodes. You can create a new cluster, give it a name, and then indicate the multiple nodes that are included. In this case, WSFC node 1, WSFC node 2, and then you can see the static IPs, and those are the secondary IPs, the 101.8, 101, and .9, 101, which are the second IPs assigned to those SQL Server nodes. So that is how that cluster is created through that PowerShell command. Now there is an additional share. This model uses a node 1, node 2, and then a witness. There's actually a file sharing model that can be used as part of this, which allows you to point to a node outside the cluster that maintains a file share that is used for as a witness to say whether nodes are up and available. And that's part of that the cluster configuration. In this template, we actually create that as on one of the Active Directory computers. You create a folder or a network share called DC1/witness, which is leveraged as the network share for the witness node. Active Directory can be used for that. To simplify this deployment and to simplify this configuration, we chose to just use the primary domain controller. In many cases, that may not be the right choice, depending on the size of your total infrastructure. And so you could always add an additional node to this architecture, which would join the domain and be specifically the witness node and have a network share and then be domain joined. That's certainly a reasonable model. We tried to simplify the setup and also reduce costs for testing this out. So we pulled a single node out. That is something you could change as well. And you can see there's a cluster quorum definition. It's node and file share majority, and it points to that share that's available on the primary domain controller. And then the last piece is to enable the always on high availability. So this is something that's done in PowerShell. It enables that capability. For each node, it will run the SQL always on capability. And that creates the availability group and does an initial data synchronization, which will be done again by a file share that was created on the main domain controller. There's another file share called DC1/replica created by the template. That's the initial data synchronization point that's used as part of that third-party witness or replication node. Again, that could be another server. We just use the domain controller for simplicity's sake. And now you're ready to create the databases and the availability group. So the automated deployment is really the key piece. I mean, obviously, we're walking through the steps so you know what it takes to get this done. But a key component is CloudFormation can automate the vast majority of this infrastructure for you. There is a template that we provided as part of this white paper and this presentation that you can click through, and it takes about 3 hours to build the entire environment. And part of that is obviously software installation, spinning up infrastructure, creating things, waiting for various layers of the infrastructure to be ready. So you don't want to start spinning up and creating your SQL Server until it can join the domain with its provided by Active Directory. So there's sort of steps, if you will. But the full platform of what we just discussed is automated up to in a 3-hour window right now. There's about 40 different parameters in that template, and you can define them. And running this template and setting it up, and just testing to see if it works and playing with it. It takes about 3 hours, and it costs, based on the instance types that we picked by default, costs about $15. So certainly a reasonable investment to sort of see that this infrastructure works and then test it out. At which point you could leave it up and running and build a SharePoint farm on top of it, whatever makes sense for what you're trying to do from an application perspective. But now you have, in this case, a Windows Server failover cluster of 2 SQL Server Enterprise Edition nodes that are Active Directory joined. And so you have an Active Directory joined cluster of SQL Server nodes you can build an application on top of. So that's that step. Before we jump in, part 3, which is actually more of a manual step, I want to show you quickly some of the template stuff. And I'm not going to spend too much time here because there's several thousand lines of CloudFormation behind this that actually help build this whole thing out. But I want to sort of show you some of the components that are in there. So the SQL Server Always On has a master template. That master template actually launches 2 sub-templates. This is a core element of CloudFormation. CloudFormation doesn't have to be a single template. You can break it into components. So this master template creates the Active Directory infrastructure, which is one step, and then turns around and creates the SQL Server always on infrastructure, which is the second step. So as we talked about, there's a whole bunch of different controls or parameters. So you can see here in the parameters section, you can choose instance types. We're using for the Active Directory M3XLs, but you can use any other instance type that you see makes sense. So you can control that. NAT instance types as well, remote desktop gateway instances. These are all things that you can choose. The instance for the first, so you can see here, this is the instance type for the first Windows Server failover cluster node, which will have the SQL Server Enterprise Edition on it. That's an R3 2XL. You could choose other sizes as well. And then those are, obviously there's a whole bunch of things around DNS and NetBIOS and Active Directory setup that are in here, as well as, restore mode passwords, domain admin users. All these things are kind of part of this. And so most of this template is actually the core parameters. And so I'll scan through this to get to a little further section. This will highlight a concept that's important. One of the resource types that you can create in a CloudFormation template is another CloudFormation stack. So in this case, it's launching as one of the first resources is the Active Directory template. You can see there's a reference here to a location on S3, which points to the Active Directory template that it will launch. And so by running the master template, you're actually firing off two sub-templates. One is this this Active Directory template. You can see how the parameters from above are then passed into this lower level template. And then the other is the SQL Server stack. And so this is the always on template. So one thing that's covered in the white paper is, let's say you already have a VPC and an Active Directory infrastructure, you could choose to just run this sub template, which is the SQL Server always on, and then pass in the parameters for your Active Directory domain controller, NetBIOS names. All those things could be passed in by you. So you are then only spinning up the infrastructure associated with the SQL Server layer. So we've broken it out like that for composability and reusability, and that helps out in terms of how it might be used in you in the wild. And this is the Active Directory template, which I won't spend a lot of time on. But this actually sets up the Active Directory, the NAT instances. In fact, I'll zip down to the resources section. You can see here it's creating DHCP option sets. It's creating a VPC right here. It's creating DMZ subnets. All these things are kind of part of that core. Private subnets are created as part of this. So it's really defining the entire VPC, the Active Directory components, the remote desktop gateway, the NAT instances are actually all part of this. The other template that's embedded in there is the SQL always on template, which then creates and runs the infrastructure for the Windows Server failover cluster nodes and spins up and installs SQL Server Enterprise Edition on those. So a key thing to look at here is obviously SQL Server, service account passwords. So these are very SQL Server specific. It creates accounts for you, creates some default values. You can obviously override them. Private IPs, public IPs are all controlled and defined in here. And then resources that are created, you can see it creates like node 1. So this is the first node of the Windows Server failover cluster is an instance type. There's actually, it leverages the CloudFormation init section, which allows you to define a series of bootstrapping steps. And you can see that it does a CloudFormation setup. It does creates the RAID for you, which is the storage we talked about. It renames the node. It joins the domain. It creates the SQL accounts. It installs SQL. And then it finalizes the entire installation. So these are all steps that are part of this. And you can see the steps are then now layered below. So CFN setup is really installing and configuring the region and stack ID information. It does a CFN conf. It reloads CFN components. Make sure certain services are running. The create RAID, you can see here there's actually creates a file which does the RAID definition. So it selects disks, it selects a partition, it deletes, it does all that work for you to create and define the partition, the RAID components, and then actually join them into stripe sets, which are then made available. So you can see here's a create volume stripe. So this is really leveraging core Windows Server components and commands but have been automated as a script, which is part of the bootstrapping process. And then it stripes each of the disks. It goes to that step, and you can see further down there's renaming. You can see we're leveraging PowerShell components to rename computer, and then join the domain. And then further down, you'll see there's actually, I'll skip the create SQL account, but further down, there is the install SQL. So there's, installing the failover clustering features, installing the .NET Framework, and then there's installing SQL EE Enterprise Edition 2, PS2. And in fact, that then injects and pulls in another, PowerShell script here, which then goes ahead and starts the bit transfer to download the trial edition, depending on which version you want, installing it and creating that. So this is very obviously a layered, componentized approach for automating this entire infrastructure. So that's how CloudFormation, leveraging bootstrapping and PowerShell, can really automate the creation of this complete and fairly complex environment. You can see why it takes time. Now, the third step in this whole environment is to create a SQL Server always on availability group. This is actually a manual step. So this is one that is not automated as part of the CloudFormation template. And this allows you to create the test database and attach an existing database. So at this point, what you would do is jump into the SQL Server Management Studio. And the way you would do that is obviously to jump into one of those remote desktop gateway instances. From there, you would then run a remote desktop client to jump to one of the private IPs of one of the Windows Server failover cluster nodes, run this SQL Server Management Studio, and then make sure the setup is correct. So you can obviously connect to the new database or attach. You ensure the recovery model is set to full. That's an important step. And then you immediately want to back up. So you would do this on the first cluster in the node. This sort of starts that process. The next step is then to create that availability group. And here you actually would use the Object Explorer to create a new availability group, and then follow it according to the guide provided. There's actually in the white paper, there's sort of detailed steps with pictures and parameters you want to pass in. You create a new availability group. You want to set up the host record TTLs, and then make sure that it's then up and running. Make sure all those pieces are there. So that's the last step to create that availability group that then identifies the nodes that are inside that always on availability group. Now, the last step that's actually included in the white paper, I think, is an important one. Certainly highlights what you've really done here through this whole process, is that you can test this failover cluster in the platform. One of the nice features of this kind of a dynamic environment is that once it's up and running, the ability to test failure scenarios is fairly straightforward. So really the steps for something like this is to spin up a remote desktop connection through the gateway, start looking at the failover cluster manager, see that it's up and running, check that everything's ready to go, and then stop that primary node. So you go into the management console, right click on the Windows Server failover cluster node 1, and just stop it. And that would simulate obviously a server halt or failure. And then what will happen is that will show you that you failed over. The secondary node is now the primary, and then traffic could flow over that automatically. So all that can be automated, but it's a pretty straightforward test to ensure that's working. And then once you're done with that test, you want to reinitiate. You can bring the first node back up by starting it to the management console. And then you would go into the cluster manager and then put it back online, so that it actually would fail back over. So those are steps. That's another key step, is to show that it works. And obviously you could put an app in front of it as well to see the impacts, and how that app responds to that should be fairly seamless, depending on your application, in terms of how it connects and then fails over and reissues its queries to the secondary node. So this picture is from one from earlier. We're showing it again. This is really what's been created, obviously with the exception of the web and app server nodes. Those were there for architectural completeness. But really, it's about that public subnet and the Active Directory components, and the private subnet at the back, and then really the SQL Server instances in the middle, in that gray box, which show that it's SQL Server running any 2 EC2 instances with always-on configuration and Windows Server failover clustering. So those are the key pieces. So what we really try to do here in this webinar, as well as in the white paper, is to show you kind of the steps, but then provide you with an automation framework that allows you to spin the whole thing up, take a few manual steps at the end of that, and then ensure that it works and test it. So really our goal here is to accelerate your process of trying new things out, trying this on the platform, and then making sure it works for you. And then should you continue, obviously these templates are freely available that you can then modify and tune to your specific environment configuration needs. You may need a higher I/O for your drives. You could choose to use 1,000 IOPS or 2,000 IOPS per disk for your RAID sets. And that's a simple change. It's even a parameter in the template. So really going through and then tweaking parameters or even modifying the template is definitely the kind of the next step once you see that it works at a basic level and tuning it to your particular production or application needs. And obviously testing is a key part of that. I'm going to turn it back to Colin now for some identification of additional resources. And then we should take some questions after that. Colin?
All right, thanks, Matt. Nice job running through all that info. Before we get to some of the questions here, I just want to point to some of the additional resources that are available on the AWS website. You can see down there the Microsoft page. There's a Windows page which has more details about pricing and some of the different instances that you can run Windows on. The next one is linked to our AWS QuickStart page, which is a new program that we have, which allows you to launch these CloudFormation templates directly from that web page. So it's included in the white paper PDF as well. But if you want to just launch that template right from the page, you can do that there. Any questions about that program? We have the QuickStart at Amazon.com alias. Some other resources there. I'll just point out the last one there is especially relevant to this solution, which is the license mobility page, and that has info about how to set yourself up for the BYOL licensing that the SQL on Windows on EC2 solution used here requires. Some other white papers there on the right, as well as a contact us form if you have any specific questions about more general questions about setting up Windows on AWS.